Fred Goldberg is an associate professor at the Royal Institute of Technology in Stockholm and an authority on polar history and exploration. He has been an invited lecturer at more than a dozen universities around the world and has participated in numerous conferences worldwide. He has published in more than 12 languages, polar history and exploration. In 2004, he formed an informal international network to study and distribute information about climate change and global warming. And in 2006, he was appointed Secretary General for an international climate seminar at the Royal Institute of Technology in Stockholm. Ladies and gentlemen, please welcome our guest tonight, Dr. Fred Goldberg.
Thank you very much for coming here, and thank you very much for inviting me to come here and speak about an important subject, in my opinion, and I hope it's in your opinion too. And let's start. First I want to start by showing some facts about climate history, which I think is important to get into the perspective here. And this shows the temperature measured from ice core in Antarctica. And these are interglacial periods, the red peaks here. And we are here right now. And what we easily can see is that the earlier interglacial periods have all been warmer than it is today. And these are glacial periods. We see 4 of them here. And when you see in the mainstream media that last year was the warmest in a million years, you can throw the paper away because this shows that that's not true. On the northern hemisphere, there's been some ice coring on Greenland, studying the temperature measured with oxygen-18 isotope in the ice cores. But we cannot go so far back. In Antarctica, we can go back 650,000 years. But here in Greenland, it's about 160,000. And today, we are here on the right side. We are 16,000 years into interglacial periods, which normally last between 10 and 20,000 years. Here was the previous one, and we can see that there were dramatic temperature changes in this period. There's up to 15 centigrade changes. That is very much. And so we have had a very stable interglacial period this last 16,000 years. And here's the last glacial period. Also, if we look at the last 4,000 years, we had a temperature peak here that we will call the Bronze Age. And we have the Roman times 2,000 years ago, the Viking medieval war period here, and we are here today. And during this period, we have mammoths walking around on Wrangel Island in the Arctic. They disappeared during this cooling period here 3,000 years ago, which astonished the archaeologists. They thought they disappeared 8,000 years ago. And if we combine these peaks, we see a straight line heading downwards. And it's getting obviously colder with years. And in order to go into a new ice age, we need an average temperature of 4 centigrades lower than today, which means that if we extend this line 4,000 years to the left, we are 4 centigrades lower in temperature. So we are approximately 4,000 years away from the next real ice age. But that is not something we have to worry about today, fortunately. But there are other things we need to worry about, which I will come back to. Oops. If we look at the last 150 years, we see the temperature down here, and then suddenly 1910, it starts to move up rapidly to 1940. Put these years into your memory. And then from 40 to 77, we had a cooling period. And then the temperature started going up again, parallel to this line. I confronted the founder of Ipcc, Bert Bolin, with this diagram, and he said, well, this is a natural warming, and this we can't explain, and this is caused by humans emitting carbon dioxide. And I had some interesting disputes with Bert Bolin. And a few months before he died, he gave a lecture at one of our Rotary clubs in Stockholm. And the people there, they called me up and said, "Oh, you must come, ask questions. Bert Bolin is the speaker." Okay, I come. So when Bert Bolin finished, everybody was looking at me, waiting to hear the first question. And my first question was, "Well, you have talked a lot about carbon dioxide as a greenhouse gas, but you never mentioned a word about water vapor being a greenhouse gas. Perhaps you could tell us how much of the greenhouse gas is water vapor." And he didn't look very happy, but to my surprise, he said 90%, which was more than I thought he would admit. And I said, "Well, that means that carbon dioxide could not be more than 5%, which means it's insignificant as a greenhouse gas." And he didn't say anything. And then I asked him, what was the question? My memory is getting bad with age here. But I think it was something about the fact that we have emitted a lot of carbon dioxide the last 15 years without any global warming. And he admitted that, and he fell off the throne at that meeting, and people were quite shocked. Well, the reason we have a cooling here, I will come back to, and also why we have an increase here. There are explanations for that Bert Bolin did not handle. But in 1977, the experts, I should say, they were warning for the big freeze, the new ice age coming, big articles in Time magazine. And 3-4 years later, the same people were warning about humans causing global warming. So that's one way of getting attention in the media. And then this is the British Institute, Hadley Institute, putting it down the global temperatures month by month. And here we see a very rapid increase. And this, of course, is said to be caused by human emissions. Well, what really took place is the following. Here you see the global average temperature year by year. And here's the amount of weather stations recording the temperatures. And they slowly went down, and here's something dramatically happened. They fell down very rapidly. At the same time, the average global temperatures jumped up quite a bit. And what happened here? Well, the Soviet Union collapsed. Not only Soviet Union, but more or less all their weather stations in the Arctic. So suddenly there was a heavy unbalance between cold and warm stations, making the warm stations dominate, and the global average temperature skyrocketed, as we see here. And that is what you see here. It's how you select cold and warm station and make an average temperature. I mean, it's, in my opinion, not impossible to calculate the global temperature from surface stations. And why, I will show you soon. How accurate are the temperature measurements? Well, to start with, 90% of these white boxes are on land, but land is only 30% of Earth's surface. So there's a major error in these measurements. Then we have the urban effect. And we can start by showing the Observatory Hill in Stockholm, where I live. It was built in the mid-1700s, and it was way outside the town. And so the bustle of town had no influence out here. Today, the same observatory exists, but it's more or less downtown Stockholm situated with a little park around it. And of course, it is affected by all the traffic and heating and whatever you find in a large city. And when I live 10 miles, well, that's less than 10 miles from this place, but I can read the temperature in my car, and when I drive to this place, the temperature difference is between 2 and 3 centigrades in the colder part of the year, which means at this time of the year, I register 2-3 degrees warmer here than at my house, a little bit away from it. That's the urban effect. One example we can see is from the Japanese city of Osaka, a large industrial city today, and it became large industrially during the war, and you can see how the temperature goes up here. 20 kilometers away from Osaka is a small village, Maizuru, and there's no temperature increase during the same period. So the difference here is the urban effect. Another error is incorrectly positioned measurement stations, and that is a common problem. I'm not showing you too many, but this is one example from Melbourne, Australia. It's downtown in a street corner, and of course you don't measure a natural temperature from this area of the world on this site. And then we also need to know that 54% of all stations used for the global calculations are airports. And of course, an airport collects a lot of heat from planes taking off or landing. Also, the tarmacs collect a lot of heat. So it's not a very good place to measure. And also, sometimes they're affected directly by exhaust from the airplane. You see the temperatures are here behind the exhaust from a jet. And I've seen this example on many places. One of them is on Spitsbergen. I saw a Russian jet blowing hot air about 50 meters from one of those. And they are now moving this station. I met a guy and had a dispute with him in Poland in August last year. I met the guy who was in charge, and we had a pretty rough discussion. Oops. So the faulty measurements of the global temperatures are due to faulty position temperature stations, as I showed you, the urban effect, the fact that 90% are on land, and also manipulation of temperature data. We discovered a few years ago that all the temperature measurements from Australia and New Zealand were showing a rapid increasing temperature over 100 years. But when they discovered that was not correct, and they corrected it, it was a flat line across 100 years. So, in my opinion, there is no global temperature. There's a northern hemisphere average temperature and a southern one. And the southern one is constant for the last 100 years. And that's because we have very cold water circulating around Antarctica, blocking any warmer influence from the north. And of course, the Antarctic continent makes sure it's pretty cold on the southern hemisphere. On the northern hemisphere, we have climate changes due to solar effects and due to ocean currents, which I will come back to. This is an interesting diagram our friend Roy Spencer put together. It shows 70 climate models that they plotted here. The average of these 70 is this black line. And the blue and green dots are measurements from satellites and balloons. And we can see there's not much change in this area. And the models are showing this. The difference is increasing each year. And the Ipcc, they said 2007 that now it's 90% sure that humans are affecting the climate. And last year, 2 years ago now, they said now it's 95% sure. But this diagram shows the opposite. The difference between reality and models is increasing every year. But then the question is, why do you have 70 models? I mean, if you have one correct model, that should be sufficient. But they have cost billions of dollars, maybe $50 billion of dollars. That's the cost for this, for nothing, no good use at all. And why it's not good is here. The Ipcc climate people, they have very little knowledge about cloud formation. And the amount of cloud cover on Earth is very important because that's a major factor influencing the climate. But it's very difficult to calculate that, so it's not in the models. At one meeting, also a Rotary meeting, the head of the Stockholm University Meteorological Institute gave a climate lecture. He's an old friend of mine. I didn't want to embarrass him too much. But I asked one question, and that is, how large is the average cloud cover on Earth? And he said, I have no idea. And I said, well, if you don't know, how can you make a climate model not knowing what the most important factor is? And he gave up. And was embarrassed and went home and started screaming and yelling probably. And also, the climate is a chaotic system that is fairly well known, and therefore it cannot be modeled. People who have some knowledge in mathematics, they know that it's impossible to model a chaotic system. So you could scrap any model based on that fact. Another important issue is that no climate model has been verified. And when you deal with models, you can't use them until they have been verified. That's common practice in any field of economics or whatever. But no climate model has been verified because it takes at least 60 years to do that, because the shortest climate cycle is 60 years. So there's a third reason why you can throw away any climate model. The only way to have a decent measurement of temperatures globally is made from satellites, because when they circle in a polar orbit, they cover all surfaces of Earth, oceans and land masses. And they give a fairly accurate result, which is reported by Roy Spencer from the University of Alabama in Huntsville. And when we look at the satellite measurements, we can see that since 2002, when we had the solar intensity maximum, there's been no climate temperature increase. There's been changes up and down, which are caused by El Niños, La Niñas, volcanic eruptions. They caused this change, but the average across here is unchanged, more or less. And we have emitted 500 billion tons of carbon dioxide in this period. And I asked a panel of 5 climate experts in Sweden, how come there's no temperature increase despite we have emitted 500 billion tons? And nobody wanted to answer that question, but after a while, one of the Norwegian professors stood up and said, it's something wrong with your logic inside your head. That was the answer I got. Very interesting. What was also interesting was that the Swedish National Radio Corporation was there. They recorded my question and recorded the answer. And it was broadcast 6 times this week all over Sweden. So I was quite happy with, with that day. At the same conference, there was a woman professor, Gunilla Svensson, and she was summarizing an update of Ipcc 2009. And the update said that the global warming is continuing, and the ice in the Arctic is melting at an accelerating pace. So I asked her and said, oh, that's interesting, but how much has the ice decreased since April last year to this year? That is 2008 to 2009. And then she blushed and said, well, it has actually increased. Well, I said, you just said it was melting at an accelerating pace. Well, that was maybe not up to date, she said. Well, I'm sorry, but we came here to be updated. What's going on here? And there was a big audience, and everybody jumped in their seats and was beginning to understand that something fishy was going on. And she was not very happy, and I took her down with a big bang at the Royal Academy of Science 2 weeks later. There were 50 professors from the academy there wondering what the hell was going on when I asked her if she knew what PDO was, and she didn't. And I said, well, that's a pity, because if you did, you would have given us the correct explanation why the ice is increasing in the Arctic right now and not decreasing that you claimed 2 weeks ago. And she turned red and disappeared. Here's a more detailed diagram from Roy Spencer, and we can see that there's rapid changes due to El Niños, and we just now experienced the last 2 winters we experienced the strong El Niño, the strongest one since '98. But that doesn't mean that this will last for long, of course. Now let's change subject and go into greenhouse gases. What is a greenhouse gas? Well, it's a gas that absorbs infrared radiation in the interval of 1 to 20 micron that's leaving Earth's surface. And the system is that when you see the sun shining, it's heating up the ground. And then in the evening, you can feel that the ground is still warm, which means that it's emitting heat. And that heat is in this range here, but the sunshine is over the whole spectrum. So the ground transformed the heat into radiating back this thing here. And the atmosphere contains today of 400 parts per million of CO2, which is very, very little. In physical chemistry, you call it trace gas because it's so little. But it also contains 30,000 ppm water vapor. And because of that, we say that 95% of the greenhouse effect is the water vapor. I saw a French report recently indicating 99%, and that CO2 was half a percent or something. But there are different opinions from different scientists. But we're on the safe side if we claim 95% being water vapor. CO2 stands for 1.5% or less of the greenhouse gas. So it's easy to understand for anybody that CO2 is insignificant as a greenhouse gas changing the climate. Here we can see the absorption diagram. So here we have 1 micron and here we have 20 microns. And here we see that it's water vapor absorbing the first part here. Here's 4.2 microns. There's a narrow peak where CO2 is involved, and there's a big area where you have water vapor absorption. Here is no absorption. And that's why you find ice on your windshield coming out in the morning. If it was a clear sky during the night, you got freezing on your window because all the radiation goes out and it's not reflected back by the clouds. And here 14 to 16 microns, there's CO2 again being overlapped with more water vapor. So it's easy to understand that water vapor is 95% here. Now we come to something called the carbon cycle, and this diagram is made by NASA Earth Observatory. And in the atmosphere, we have today something like 800 gigatons of carbon in the shape of carbon dioxide. We used to say carbon because it reduces the number figures there. And in the oceans, we have 50 times more, 38,100. And this is a natural balance. If you have a beer bottle, you have carbon dioxide in the beer, and you have carbon dioxide above the beer surface. And it automatically distributes 2% in the air, 98% in the beer. Or if you have mineral water, it doesn't matter. It automatically adjusts. And that's what's happening between the oceans and the atmosphere. Then we have the biomass. We have the chlorophyll process. It absorbs CO2. And we have the oceans absorbing 92 gigatons. Cold water absorbs carbon dioxide. Warmer water emits carbon dioxide. So depending on where on the globe you are, you find carbon dioxide leaving the oceans or being absorbed. Then we have ourselves, human emissions. Here it says 5.5. This was a couple of years ago. Today we're up to between 8 and 9, which means that we are emitting 1% of what is already there. Then the interesting question is, what is the time that the carbon dioxide remains in the atmosphere, considering the absorption in the ocean and the biomass? By the way, the biomass is absorbing carbon dioxide, but it's also emitting carbon dioxide when biomass is rotting. It's giving back the carbon. So it's a zero balance, the biomass here, actually. But if we look at the numbers, we have 800 gigatons of carbon in the atmosphere. The biomass absorbs 121 gigaton a year, and the oceans 92. If we add these two together, we find that 28% of all the carbon dioxide in the atmosphere is absorbed each year in a natural cycle. And the human addition is 8-9 tons. That's 1%. And if which means that the human total addition to the atmosphere is only 4%. So out there, the amount of oxygen produced by us is 4% of the total amount, which is still very small. And the total amount of human emissions is 33 billion tons of CO2. It's quite a bit. And it's absorbed by the oceans and the biomass in how many days, do you think? Anybody have a guess? Days, months, years?
2 years.
2 years, good guess. 15 days, that's all it takes for nature to absorb all our emissions. As I said, the CO2 share of the greenhouse effect is 1.5%. And the human share is 4%. When we multiply these two numbers, we come up with 0.06%. That's the human effect on the climate. It's so small you can't measure it, of course. So that's the real human effect on the climate, 0.06%. Does the atmosphere warm up when you emit CO2? Of course not. Oops. Here's an interesting observation that my friend out in Copper Mountain, Colorado, Martin Hertzberg, made. He shows here the fossil burning. Here's 1929. Then we have the Depression, and the fossil burning went down 30%. During the same period, the temperature increased, and also the amount of carbon dioxide in the air increased, despite this 30% reduction. We see no correlation between our emissions and what's happening out there. But it can be explained, which I will do. Also, if we look at this diagram made by Ilya Aronov, the advisor to Putin, but when Putin didn't listen to him, he left and came to the US. And oops, and here's 1910, and it started to get warmer, and the carbon emissions were just a little bit increasing. But then 1940, the World War started, the emissions increased dramatically, as we see here. At the same time, it became cooler. The temperature didn't increase, it became cooler when the dramatic increase came. And then after 77, the increase continued, the temperature also increased. So this also shows that there's no correlation between the amount of carbon dioxide emitted and temperature changes. Another factor you never hear about in the media is called in physics the saturation effect. It means that the amount of carbon dioxide in the atmosphere is not correlated to the greenhouse effect. You saturate it at a certain level, there's no more influence of carbon dioxide. It doesn't matter how much you add on. You can only paint a glass window white until you can't see through it. Then it doesn't matter how much paint you put on it, it's still white. And here the diagram fools you a little bit because it starts at 230. So you have to think this line going down below the floor here. So the first molecules have a very strong greenhouse effect, and then it tapers off here rapidly. And if we look at the year 1900, we had 280 ppm in the atmosphere, and that corresponds to 257, 58 watts per square meter forcing. And then if we double that value, we end up to 560, and we come up here, and it's 261. It's only 3-4 watts change. It's not 500 watts change, it's just 3-4. And that shows the saturation effect. Today we have 400 here. If we double that to 800, it's just a few watts increase in forcing. So we don't have to worry about increasing temperatures the next 100 years or so. We can also display the same effect by histogram made by Archibald from Australia. And here we see the first 20 molecules. They made an effect of 1.5 centigrade. The next 20 molecules, 0.3 degrees, 0.2, then it tapers off. And 100 years ago, we were down here, 280. And over the 100 years, we increased the carbon dioxide 30%, but the temperature effect was only 0.2 centigrades. And another will be less increase and so on. This is also one of those interesting diagrams for our course. The red line shows a model how the temperature will increase with increasing CO2. Well, the real world is down here showing a constant temperature and the difference is increasing every year. So this is based on models, of course, it says up here, and has nothing to do with the reality. So why has there been a 30% increase of CO2 during the last 100 years? Well, as I said, it depends on the temperature of the oceans. And during the last 100 years, the solar intensity increased, coming back out of the Little Ice Age, and it peaked at 2002. And the oceans were warming up about 1 centigrade, which released carbon dioxide. The problem is that very few scientists in the world know how sensitive the oceans are to temperature and the release of CO2. I've been searching that data for a long time all over the place, in Handbook of Chemistry and Physics, and so on. But I happened to bump into one professor from Columbia University. And here I had to make my own diagram to show for fresh water at 5 degrees temperature, it absorbs 3 grams of carbon dioxide. At 25 centigrades, it absorbs only half as much. That's why when they produce mineral water, sparkling water, the water temperature is 5 centigrades. And then you pump in the CO2 and it's instantly absorbed at that temperature. And that goes for beer too, of course. And also the oceans are pumping the carbon dioxide in and out with the seasons in large volumes. But what happens if you have ocean water? Well, the result I was told is seawater absorbs 73 times more CO2 than fresh water. And that's why we get this 30% increase when the oceans were warming up only 1 degree. That was enough to release 30%. And here we see a diagram of the sunspot frequency over 100 years here, this red curve. And here we see the sea surface temperature following in parallel very accurately. And when the sea surface temperature is increasing, it releases carbon dioxide. So this is the accurate explanation. Another strange thing is that human emissions are constantly slowly increasing according to this purple line here. But the increase year by year varies very strongly. You can see this year here, we had a 5 gigaton increase, but here we had only 1 gigaton, but the emissions were larger. Despite that, the increase was less. There's absolutely no correlation between emissions and the changes each year. Well, the solution to that is if we put the temperature changes in here. The temperature changes with El Niños, La Niños, and volcanic eruptions. And here we can see very high correlation between temperature change and how much carbon dioxide is released to the atmosphere. We have a super El Niño in '98. That's when we had the highest peak of CO2 in 1 year. And then we had a low peak when we had La Niñas, or the large Pinatubo eruption. That was the lowest one for 100 years, was down here. So in April I will update this diagram up to this stage, but it will continue like that, being very correlated between temperature and amount of CO2 being added to the atmosphere. Here's a paper published by Bert Bolin in his younger years, 1959. He published it with his boss, and it was about the change of carbon dioxide content of the atmosphere due to fossil combustion. It was popular already in 1959. And there were many papers published on this subject. You see 30 of them listed here. And the one down here is the paper by Bert Bolin and his boss Ericsson, showing 4 to 5 years residence time in the atmosphere. And most of them are below 10 years, except the Ipcc report, the red line, claiming 500 years. And the diagram only goes to 100 here. And you wonder what documents this is based on. And I challenged Bert Bolin on this, and he had a big problem answering it. Do ocean currents have an effect on the climate? Next issue. Well, it's fairly new to many people that there is an ocean current called the Pacific Decadal Oscillation, PDO. And it has a 60-year cycle. 30 years, it's positive, and warm water is coming from the equator, coming up the west coast of the US. Some of the water goes into the Arctic Ocean to Bering Strait. Suddenly, it reverses in the other direction. No more water, warm water goes into the Arctic, and things get colder. And here you can see a diagram showing a positive PDO when it's going anti-clockwise, and a negative when it's clockwise. And the changes happened 1910, 1977. So the reason we had a cooling from 1944 to 1977 was because of this ocean current being negative. Something Bert Bolin didn't know, of course, when he said he couldn't explain it. And then it reversed again, and the temperature went up. So the climate change is primarily caused by this Pacific Decadal Oscillation. And we can also measure the average global annual temperature on the Alaskan coast. Here we see a diagram from Kodiak, where we had, where we had dramatic increase, almost 10 Fahrenheit in average annual temperature because of the sudden flow of warm water coming up through Bering Strait. And we see the same thing in Nome, in the middle of Bering Strait, a dramatic increase over 2 years. And then it slowly tapered off. But of course, they report an increase with this line, which is very incorrect because it should be a line coming from that point down instead. Lennart Bengtsson is a very well-known Swedish climatologist and been working with models most of his life. He's been working at Max Planck Institute. He and I have had some arguments on the internet, and he published this diagram showing the temperature increase, and this dramatic increase here, he says, is because of human emissions. I said that he's wrong, and in my opinion, it looks like this. It's going up and down like this. And the reason is PDO is positive, negative, etc., coinciding with 1910, 1940, 1977, and 2008. I happened to be in California in 2008, giving a lecture at California Institute of Technology. Then we went, my wife and I, to Tucson, Arizona to see friends, to play golf. When we woke up in the morning, there was no water in the bathroom. When I was going to take a shower, my host woke up, and we discovered that all the water pipes had frozen in the house. It was -5 centigrades outside. Never happened in the history of Tucson. It was the PDO that switched. The fruit harvest the fruit harvest was destroyed at the bill of $1.5 billion, as you know. And I met a very distinguished economist, Swedish, what was his name? Kjell Nordström. We sat next to each other on a flight to South America. And I asked him, do you think that the fact that $1.5 billion disappeared from the market could have caused a financial crash? And he said, well, I haven't thought of that, but that could be very possible. If suddenly $1.5 billion disappears, there's a problem, the domino effect starts. So it could have been the cause for the financial It would have happened anyway, we know that, but something had to trigger it, and I think this triggered it. Which factors control climate change? Well, the solar activity influences the magnetosphere, and I don't have time to explain this more in detail. It's a Danish scientist called Henrik Svensmark who discovered this, who has been harassed by governments all over the place and lost his funding and everything, because if people accept what he's saying, Ipcc falls together like a card house. But what I believe is true is what he says. He will have the Nobel Prize, but it will take a few more years. But when the magnetosphere is strong, the cosmic radiation from exploding stars out in Milky Way will be, what you call it, deflected back. It doesn't come into our atmosphere. But if the magnetosphere is weak, which it is, if the solar wind is weak, then the cosmic radiation goes into our atmosphere and it forms clouds. And we have more than average clouds and it gets colder. So it's the amount of cosmic radiation caused by the solar wind that decides our climate primarily. And secondarily, we have the effects of the ocean currents, volcanic eruptions, and so on. But the primary effect is what's going on with the sun and the solar wind. And the secondary effects is ocean currents and so on, and the volcanic eruptions. What will the climate be in the future? Well, many people want to know that. And I was invited keynote speaker thanks to Admiral Lawson Brigham, who had to cancel his speech at the Polar Conference in Sweden. And I said I can step in for him. He's a friend of mine. And they accepted my suggestion. And the conference was about setting up harbors in the Arctic. Now that all the ice is disappearing, we can send ships over the North Pole and all that. So all the people, building harbors, building ships, and God knows what came to this conference. And then I told them the real story. And they were, of course, very shocked and put the coffee in their throat. And I said also to them, according to my studies, we will have a very cold winter coming up, 2010. And they got their coffee twice in the throat. And they didn't believe me, of course. But when they discovered they froze their butt off the coming winter, they came back to me and said, oh boy, you were right. What's next winter going to be? I'm sorry to tell you, but it will be colder. And then they hurried home and isolated their houses and bought a new snow mover, etc. And I was right again. And it was quite fun. But that's when you look at the solar cycles. There are different cycles. The shortest one are 11 years, the sunspot cycles. But then you have about 6 important cycles that Habibullah Abdusamatov have identified and added them up. And what we can see here is that the sunspot frequency has been fairly even over a long time. These are these 11-year cycles, sunspot maximums, and the minimums are changing a little bit. But then suddenly it dropped down to almost 0. And there was normally this cycle should have stopped here and gone up again, but instead it went down here and stayed down here 2-3 years. And that helped cause this cold winters I predicted. Also, there's a 200-year cycle. So if you look at Napoleon losing his army outside Moscow because of extremely cold winter, you just go 200 years forward and you come right on the dot to what happened 2010-11. Well, this is Habibullah Abdusamatov's diagram, adding all these cycles together. And he discovered that the sum of the cycles ended up down here, which is the same level as during the Little Ice Age. And he fine-tuned his studies. And we can see here that the cycle 23 peaked up here. The next cycle was 2014. It peaked on half the level here. and the next cycle will peak somewhere around here. So the top of the peaks are coming down. And this is Habibullah's last diagram. This was the 24th cycle up here, being half of this one. The next one will be down here, the next here. So in the next 20, 30 years, we are going rapidly down to colder climates, the Little Ice Age. And we will probably see London River Thames freeze again. They will have nice markets on the ice there. Prime property for nothing. And what will this lead to? Well, it will lead to less food production, probably something like 20 to 30% less food in this country and perhaps even more in other marginal countries. We will have, the result will be increased food prices that will hit poor families heavily. It will cause famine disasters that will it will trigger wars. That is a very common situation. We will have a higher energy consumption, which will cause higher energy prices, again hitting the poor people. And we will have some very cold winters, good for ice skating, good for polar bears, more traffic accidents, and so on. So we have nothing positive to look for. Only the polar bears are very happy about it. Can humans change the climate? Judge for yourself. Thank you. Thank you very much. Well, I'll be happy to answer questions. Hopefully I can.
And I will bring the microphone to somebody who has a question. We have a couple of questions online in our chat as well, so we'll be getting to those in a moment. So you first, Mr. Bast.
I'm wondering, Fred, are you actually predicting observable cooling in coming years, in the next 5 to 10 years? You really think it's going to be noticeably colder?
Yes, well, we can't notice it until it has happened, of course. But we had 2 warm winters, hardly any snow where I live in Stockholm. Normally we get 1 to 2 feet snow in a season. This season we had 1 or 2 inches. But that's because of the very strong El Nino that we had this last 2 winters. So we shouldn't be fooled thinking that there's some average global warming going on. We will probably have a pretty good, decent winter next season with enough snow to bring out the snow mover. But even during a little ice age, we have experience from the 1600s, and we have a lot of written records from that time. So we had warm summers, nice summers, but we also had very cold winters and bad winters, people starving and so on. That will happen again.
Fred, thank you so much for the presentation. I thought it was fascinating. Early in your presentation, you showed a graph with temperatures going back over the past several thousand years, in which temperatures currently were cooler than most of those years. We're often told that carbon dioxide, atmospheric carbon dioxide concentrations are the primary driver of global temperatures. Can you tell us what atmospheric carbon dioxide concentrations were several thousand years ago when temperatures were so much warmer than today?
Well, if you go back millions of years, the geologists can tell by the amount of marble that was formed in those days. And I think I can recall that how long time ago it was 3,000 ppm carbon dioxide when the average global temperature were 22 centigrades. Today it's somewhere around 14.5. But it was 22, and that's the maximum it's ever been. And of course, when it's that warm, when the dinosaurs roam around, it was that kind of temperature. And then, of course, the oceans were warmer and releasing all that carbon dioxide. So the amount of carbon dioxide in the atmosphere is directly correlated to the sea surface temperatures over the years.
But 4,000 years ago, relative to today, temperatures were much warmer.
Yeah, it was 3 centigrades. So there must have been much higher carbon dioxide concentrations in the atmosphere at that time, yes.
Okay, and I forgot to mention, please identify yourself so that Dr. Goldberg know who he's speaking to.
Hello, I'm Larry Greenberg, and my question is this. Back in the days of fear of global cooling 30 years ago, 40 years ago, we were motivated by clean air to reduce the concentration of carbon dioxide, sulfur dioxide, et cetera. And a number of governmental programs were put into place, certainly in this country and in many other Western countries, to cut that down. So perhaps, although maybe not so much in China, we have eliminated or greatly reduced the health impact of carbon dioxide, sulfur dioxide concentration. So now we have fears of global warming from carbon dioxide. What's the actual health risk to human beings of carbon that we breathe?
You're bringing up a very important subject, and what is important is not to mix up climate change and pollution. They're two very different things. I mean, when you burn coal in a plant, you generate carbon dioxide. That's not a problem. But you also generate sulfur, heavy metals, and other not so good stuff. And that is today, with modern technology, being taken care of. So the major things coming out of this smokestack is carbon dioxide and water vapor. The rest is to 99% taken care of. Not in China, though. They are badly suffering from all the pollution. But the people who promote global warming, they purposely mix up the climate change and pollution because it's easier to transmit the message, you must stop burning something producing carbon dioxide because you pollute. And that's easy to understand to people. Most people don't understand that the carbon dioxide itself is very beneficial. It increases food production, and a lot of other good things happens with carbon dioxide. And it's interesting, you remind me of something that happened 2009. I bumped into a Chinese person in Sweden, and he was very fascinated about what I was talking about, the climate, and wanted to get acquainted with me. So I decided I want to write a letter to the Chinese leadership. It was 1 month before the meeting in Copenhagen. And I asked if he was willing to translate my letter to Chinese. So he said, oh, sure. So I wrote a one-page letter explaining that in China they should not worry about emitting carbon dioxide with all their coal plants. They should worry about the pollution and make sure they don't pollute. There are modern techniques to avoid that. And guess what happened? A week after I sent my letter, I was told by the Chinese correspondent in Sweden, which I happen to know, that in every newspaper in China, my letter was published. And another week passed, and a television crew from China came to interview me. And secondly, when the Chinese delegation came to Copenhagen, when they discussed cutting down carbon emission, there was a cold hand from China right away. I don't know if it was on my letter, but maybe. But it was interesting, and it was bloody cold in Copenhagen. When I was there one day, and it was bloody cold, and the people giving money to Greenpeace and World Wildlife, they could see where their money went. It went to advertising. The whole airport was full of posters. Terrible.
Well, I guess relating to state-controlled media, maybe it's not all bad.
No, but the main issue is not to mix up pollution with climate change. And there is no evidence that carbon dioxide emissions is changing our climate. I've asked my opponents, show me the evidence. They disappear very quickly. I never see them again.
Well, speaking of that, Dr. Goldberg, I'll say hello to our people watching the live stream. We have several questions in the chat room. This is from Rick Scheck. Hello, Rick. Dr. Goldberg, you alluded to at least one Ipcc scientist who threw in the towel on AGW. Have you seen any others back away from the Ipcc's increasingly untenable position?
There have been a few. I don't know if I can recall any specific person right now, but Chris Lancy, for instance, he was submitting information about hurricanes and so on. And he said that the amount of hurricanes was decreasing over the years. But in the Ipcc report, the editor wrote the opposite. And he protested and he threatened to sue Ipcc if they didn't change it. But they didn't change it, but they removed his name from the report. So, and there's a New Zealand, probably the most knowledgeable person on climate issues. His name is Gray, Vincent Gray. He sent in 1,000 comments, more than 1,000 comments to the Ipcc report. They didn't take any one of them into account. There's another one called William Gray from Colorado. He was not mentioned in the Ipcc reports, and they asked him, well, they know my standpoint and they're not interested in it.
I got a question regarding the greenhouse gases. If I understand you correctly, there's carbon dioxide and water vapor, 400 parts per million carbon dioxide and 30,000 parts per million water vapor. Now the total greenhouse gas effect is the combination of those two?
No, we have ozone, we have NOx gases, and a few other very, very special gases that also absorb radiation and are called greenhouse gases. But methane is maybe the third most important greenhouse gas after CO2. So, but they all together add up to 100%, of course. And the methane issue is interesting because we are often told that we should not eat meat because cows and cattle, they emit a lot of methane. And I attended a conference and there was a specialist on greenhouse gases showing the curves going up in the sky all over the place. So I asked him, is it correct that the amount of methane in the atmosphere was constant from 1995 to 2008? There was no increase. And he was honest, so he said, yeah, that's correct. Well, why is that? And he couldn't explain. So everything he said fell to the ground. Of course, there is a balance, a natural balance with methane in the atmosphere compared to what's going on in correlation to temperatures. And I mean, our cattle has nothing to do with it. And I met on Greenland 2 years ago scientists working on the methane emissions from the tundra. And we are always told that it will be a disaster if the tundra melts because it will emit enormous amounts of methane. Well, these scientists looked at this and they melted the tundra under very strict conditions. And they discovered that the melted tundra absorbed 2 to 20 times more methane than was emitted. And the reason is that when the tundra thaws up, you have a large amount of bacteria that starts to work. And the bacteria is chewing up the methane, generating water vapor and CO2 and what else. So that takes over the whole process. So we don't have to worry about the melting of tundra. And with the coming ice age, you have to worry even less.
Okay.
Hold it. All right. Richard Vedder, I appreciate very much your presentation. I would hope there's a paper or something that has a number of these charts available. If not, I would like to have those. I'm going to make some comments, and then I've got a number of questions. I have been putting together numbers here for quantitating CO2 and climate change and allowing for the greenhouse gases and making a number of assumptions. One of those, well, there's more than one. One is that about 97% of climate effects is from natural sources, 3% from greenhouse gases. And of the greenhouse gases, I have numbers pretty close to what you presented. 95% of that is water vapor. 4% of that 3% is carbon dioxide, and roughly 96% of the carbon dioxide is from natural sources. So when you do the calculations, I come up with a factor of 0.0048 as the potential probability of CO2 by anthropogenic sources having an effect on climate. Now, I'm going to go back over your numbers. Hopefully I took down numbers properly.
Yeah, well, I said 0.06, and you were saying 0.48, so it's not very far away.
Not too far away, okay. Now, another comment is, I think, is it John Casey in his Dark Winter, the book he presented, he was sort of paralleling what you're saying here on sunspots. And they were looking at the next 2 decades as definitive cooling periods. Now, from that, is there, how do I say, and then are we looking at the bottoming of it and those cycles that you showed? Will we be coming back up, and would we go to another normal peak and down, or would we look at it going only X amount up and then down so that there'd be a prolonged cooling versus a more prolonged warming effect?
That would be prolonged cooling, I believe. When adding up all the cycles that the Russian scientist, he's the head of the Pulkovo Observatory. And so I think his observations and calculations are fairly accurate. I've known him for 10 years, and so far he's been very accurate.
Okay. I have another question from the live stream. This is Simon Filitro. Question for your guest: how many parts per million CO2 are humans adding to the atmosphere through fossil fuel, cement, and land use changes? Simon says he finds numbers in the range of around 5 parts per million for 2013. So how would you comment on that?
I haven't looked and calculated just that issue, but we emit 8-9 gigatons a year, and that should come up with 4.5 parts per million equivalents to that, if I remember the formula right. So it's fairly close.
Henrik Kowalczyk. I enjoyed the lecture as well, and I just happened a few months ago, I do a little bit political writing, so I used the knowledge from Heartland, and I wrote some text on the subject. And at that time I was studying the issues, and one thing which came out in reasoning of opposite side is that the very high level or the pace of growing CO2 level in the atmosphere, which grew about, like you said, about 30%, 1/3 within last 100 years, is a little hard to explain with global warming, because that level in historical times is unprecedented. That we had that high level, I think, about 1 million years or around about it. This was basically, and I think with in the data, I don't have it handy right now, but let's say we had that global, that period of warm and cooling within about that 100,000 years, cycle, and in those within that was last 100,000 or just about years, the level of CO2 wasn't as high. So basically, the argument is that the only change is the human, action.
No.
And on that margin, I just read somewhere recently, I want to ask you whether you see any reason, any sense in it. Someone said that about 100 years or 150 years ago, in the, let's say, the second half of 19th century, mostly in Europe, Northern Europe, and also in North America, there were a big reforestation projects. So basically, those trees with oaks or whatever with leaves were replaced with pines, because pines grow fast. And there was some scientific study, which I just heard about it, that pines, when it comes to that photosynthesis, don't take as mine of CO2 as oaks and other those leaf-bearing trees do. So that 100 years increase of CO2 could be explained by that reforestation project. I don't know how big those reforestation projects are. I just happen I'm coming from northern part of Poland, so I have seen a lot of forests when I was growing up, which were the pines in the rows. So I know, but I don't know if this has any bearing from your perspective.
I don't think that's correct. I understand that the increase of CO2 in the atmosphere makes trees grow faster. And somebody calculated that the total Swedish production of paper, which is pretty big, is taken from only the increase of the forest growth based on the increase of CO2. And there has not been any replacement of oaks with pine or something. They don't grow in the same areas, so it's not possible to do that kind of replacement in general. That's not a factor. But another important thing you said that is incorrect is that nobody has measured the carbon dioxide content in the atmosphere going back thousands of years properly. There was nobody having instruments for that, of course. But they measure the carbon dioxide content in ice cores from Antarctica. And they show how it changes. And there was a lot of debate if the temperature change was caused by increased carbon dioxide or not. And then when they analyzed it carefully, they found that the carbon dioxide increase came after the temperature increase and so on. But the bottom line is that it's not possible to measure carbon dioxide in ice cores because there's a publication made by the Norwegian Polar Institute and also a Polish scientist, Jaworowski, who was a good friend of mine, that showed 20 reasons why it's not possible to measure carbon dioxide in an ice core. So all those values are incorrect that are published. And they show 180 ppm and that kind of area. Well, the evidence that it's all wrong is that if there was such a low level of carbon dioxide in the atmosphere, all our plants would die. They need more than 200 ppm to survive. So they would have disappeared, but they didn't. Obviously, it's incorrect. But also, there's a Dutch team in Utrecht who studied previous carbon dioxide contents by studying the amount of cells on the back of leaves. And the more carbon dioxide in the atmosphere, the fewer stomata cells they have, because they want to have as few as possible, and they will absorb the carbon dioxide for the chlorophyll process. And by finding plants that's growing in the same place over 10,000 years, there are a few places they found that, and they could show the dramatic change of carbon dioxide in the atmosphere 11,000 years back, and at certain points showing completely different results. And I personally went to see one of these guys in Utrecht, and he was a little bit worried to say too much, because if they are considered talking against global warming, their funding disappears. And he was a bit worried about my visit. But I found out that the people coming out with CO2 data from ice cores wanted to calibrate it against the stomata cell studies, which is pretty funny. But the stomata cell studies, I think, are pretty accurate. And they show the opposite to what you say. And the basic physics is that the water temperature in the oceans decide how much carbon dioxide we have in the atmosphere. That's fairly obvious.
Two questions. One is, do you know when most of these climate change modeling, do they start at the end of the little ice age, or do they go back into that previous 400-year warming? That's one question. Number two is there's a lot of talk or discussion on the acidification of the ocean due to the CO2, and of course due to anthropogenic releases on that. I would appreciate you addressing both of those questions.
Well, I am not a model specialist. What I explained here is that you cannot model a chaotic system. So that knocks off all model discussions. Of course, they tried to use known data, so that when they make their models, they use known data, but it has shown over the last years that that's the end of the model. It doesn't show correct what's going on in the future, but it's easy to make a model that fits older times. But I mean, there's so many different models, I don't know how far back some of them goes. The other issue is important issue, acidification, you said. Well, the pH value of the oceans vary between 7.8 and 8.2 pH. And that is not acidic. It's far from acidic. And I consulted a world-famous oceanographer, Erik Olausson in Sweden, and he told me that this is the average value around the ocean, and it varies for various reasons depending on how much minerals it is locally in the ocean and so on. But when I talk to chemical experts that have looked into this, one of the experts is Tom Segelstad in Norway. He's shown me the diagrams that it's impossible for any amount of CO2 to acidify the oceans. The oceans have so much buffering of salts and minerals that it's impossible to change the pH value. So all talk about acidification of oceans is a hoax. It has happened in certain bays on the west coast of the US, where there probably has been pollution from farming and sulfur stuff coming out into a local bay where it has been concentrated. And there they make the measurements and trigger the alarm and get publicity and all that kind of thing. But overall, it's not possible to change the acidity of the ocean, fortunately.
Okay, we have another question from our chat room watching the live stream from Rick Scheck. Hello, Rick. He writes, the catastrophic CO2-driven temperature increase requires a significant positive feedback to work. Seeing as how negative feedback is the norm, natural balance of nature, are you aware of any examples of meaningful positive feedback anywhere in the natural world, especially when it comes to the climate?
Well, that's a very good point. I mean, if there was a positive feedback, we would have gone overboard a long time ago. So there is no example of positive feedback in nature. That's just a fact.
One quick question. Most of the graphs that you showed, if I'm reading them correctly, show either very weak or even negative correlation between the CO2 levels and temperature. So when social scientists look at this as opposed to real scientists, that is to say the people who presumably are looking at real data and observation rather than models, why aren't people in the social science business saying, they usually say that correlation is not causation. In this case, it's the opposite. I mean, it's absurd. Am I wrong?
Yeah, no, I agree. Now, the sad thing is that the politicians have decided what's going on. It doesn't matter what the scientist says. And I mean, you can start by looking at the Ipcc founding charter, which was made up by Bert Bolin and Maurice Strong. It says that the purpose of Ipcc is to show that humans are changing the climate. That's the purpose. So yeah, it's theology. So I mean, it doesn't matter. Therefore, they neglect all reports showing the opposite. They're not allowed to show that. And a typical interesting thing that happened recently, I saw in a newspaper a month ago in Sweden a citation which says that the climate threat is a theological issue. And I showed that citation at my talk at Rotary, And I asked, who said this? And in the audience, there was a priest. So I asked him, who said this? And sure enough, he said, the Archbishop. And I said, yes, you're right. It's the Archbishop. It's a pity she doesn't know the difference between faith and facts. That's the issue.
I'm going to read another question from online, but if somebody, we have time for a couple more questions, so if you have one, please raise your hand when I'm finished, and I'll come to you. This is from J.C. Lampy on our chat room. He or she writes, do you think this debate is more about science or politics? I think we've kind of answered that through the discussion here. But it actually, yeah, it brings to mind where the debate is going on. It brings to mind the Paris Agreement that the President Obama is going to sign that in a ceremony at the United Nations on Earth Day, also Lenin's birthday, April 22nd.
That's interesting.
Yes. And so what I'm interested in is what is the attitude in Europe, what's the political feeling in Europe like about this Paris Agreement? Because we've called it Victory Over Global Warming Day at the Heartland Institute because the accord is so toothless and meaningless. It's a complete empty gesture.
Yeah.
But that's our attitude. What is the attitude in Europe? Because they sure left Paris acting like they won the Super Bowl.
Yeah, well, it's mixed, depend how you talk to. And I mean, people involved in politics and environmental issues, they think they won the war, but they won the battle, but they didn't win the war, that's for sure. And then, of course, people like me, we are very upset about how 195 heads of states, can agree on something they don't understand. And interesting, I became a good friend of President Václav Klaus, thanks to Heartland Institute. And he told me that he attended a meeting at United Nations with all the heads of states about the climate problem. And all of them, except him, he said we must do something about carbon emissions and so on. And he said the opposite. Then afterwards, he told me that 4 or 5 of the other heads of states came up to him and thanked him for his speech because they agreed with him, but they didn't dare to say it. That's how bad it is.
Anyone else got any questions here in the audience? Well, here's something we definitely must do, and that's give our presenter tonight, Dr. Fred Goldberg, a very great round of applause.
Thank you.